Alright, so now what we have to do is to write a recursive function that will be able to find out the sum of all digits in a given number. And we know that it can be easily done by using some iterative approach. You simply take a number, let's say 213, and you know how to sum all of its digits by simply every time taking the right digit, for example 3, by using a modulo, right? A modulo. And you take this 3 and you sum it to this 1, and then you take this 2 and you sum everything up and you get your 6 at the end, okay? So that will be an iterative approach where you take this number, take the modulo divided by 10, take the right digit and then divide the whole number by 10, and you just remain in the second phase with 21, then you stay with 2, and every time you take the right digit and you are basically okay. So now in the recursive approach we are going to use something very similar, okay? So we know that to find out the sum of digits, let's call it sum of digits of let's say 213, it is simply, that's our main problem, okay? And we are looking, because we are using recursion, we are looking to find some relation to a subproblem. So we know that sum of digits for 213 equals to 3, okay, plus sum of digits for 21. And the reason for that is very simple. We are going to take the right digit, in this case it's 3. We know that it's 3 plus sum of digits for 2 and 1, and remove this digit because we also already took it into our considerations. We will remove it and call this function in a recursive manner. And we know that this problem, this subproblem, can be divided even further. So we will keep this 3, so it's 3 plus sum of digits for 21 will be equal to 1, right? The right digit, plus sum of digits for 2. Because 2 is what remains if we divide 21 by 10. And we know that that's kind of a trivial solution, because sum of digits, when you have just one digit, is just the digit itself. Whether it's 1, 2, 3, 4, 5 or whatever, it will be the digit itself. So that will be used for our stopping condition, for our base case, and we can see that we were able to take a bigger problem, and to find some rules, some regular things that we can do to divide it into subproblems. So we just extract the right digit, and then we call this function a recursive call of this given num divided by 10. So 213 divided by 10 is just 21, okay? So 213, and we get 21. So that's great. Now let's see how we create a function for it. And this function is going to be int sum of digits, and it will return some number, okay? And what we are going to do here is, first of all, we need to specify the stopping condition. So in this example, we said that the stopping condition, the base case, is going to be when we have just one digit. And since we are working with integers, it's going to be very simple. We just need to specify as long as if num is less or equal to 9, okay, meaning it's less or equal to 9. It can be 9, 8, 7, it can be 0, okay? So if that's the case, we are going to return the number itself, okay? So it's trivial, we can find the solution right away. We don't need to make any division to subproblems and so on. Okay, so what will be the recursive call? What will be the recursive call? We've seen here in this example that we first of all extract the right digit, right? We extract the right digit of a given number. So that can be done by using a modulo 10. So return num modulo 10, okay? It's the right digit, the right one, 3 in this case and 1 in this case, plus what? Plus sum of digits for this 21, which is this given number divided by 10, because we don't want to include this 3 in the further sub-problem, because we already took it into account here. So it will look like this: num divided by 10. Okay, and basically we can say that's it. So let's write some simple program to test it out. So int num and printf, enter insert a number, then the user specifies scanf. Wow, I'm typing really fast today. Num, here's the mistake. And now we are going to call this function. So printf, we are going to printf right away. We are not going to create another variable to hold the result. We are going to print that sum of digits for %d equals to %d, okay? And instead of this first placeholder, we are going to use num, which is the number itself, and here we are going to use sum of digits, okay? Make this function call sum of digits for num. So instead of this %d, we will have num, so sum of digits for num for a given number, let's say 213, will be equal to %d, to this result that will be instead of this function once it's over with the execution. So let's try to build and run it and see what happens, if everything okay and we didn't mess up anything in the process. So okay, so here's the problem. Okay, so that's just a comment, don't be so mad. And now build and run and insert the number. Let's go with this example, and we know that we expect to receive 6 at the end of it, right? 2 plus 1 plus 3. So sum of digits for 213 equals to 6. Fantastic. We can use another example, let's say 999105. So we just sum it up, it's 27, 28, it's going to be 33, right? So let's print enter, and there you go. You can find your sum of digits for any positive number that you may insert it. Of course, as long as it does not exceed the integer range. So that's basically it for this video, for this challenge. I hope you tried this one on your own and you probably got it right, because there is nothing special here. We talked about how to find, how to access digits in a given number in one or two of our previous challenges, not in this section but in the previous sections, and there is nothing new here. We just used a base case, we used some recursive call, and we found out some rules for this division to sub problems. So thank you guys for watching. I hope this material is clear to you, and in the next video, in the next challenge, we are going to look for also something similar to sum of digits, but let's go there.